the interior of the Earth?
By us.
The interior of the Earth is split into four main layers. The inner core, a big ball of metal located in the center of the Earth, and then above that is the outer core, a large layer of liquid metal sitting on top of the core. The mantle is next, which is divided into three subdivisions. And finally, the thinnest layer is the crust. The crust underneath the oceans is thinner than the crust underneath the continents, as you can see in the drawing. The mantle is divided into layers depending on the properties of the rocks that make up them. The three layers are the lithosphere, which contains the slow-moving tectonic plates, the asthenosphere, a hot semi-liquid zone which the lithosphere sits atop, and the mesosphere, the strongest and lowest part of the mantle. The crust is anywhere from 5 to 75 kilometers wide. The mantle is 2,850,000 kilometers long. The outer core is 2,260 kilometers long, and the inner core is 1,220 kilometers long.
Earthquakes start at the focus point. The focus is where the ground ruptures and seismic waves radiate energy. Above this is the epicenter, which is the surface of the Earth right above the focus. When tectonic plates move, they send out lots of seismic waves. In this model, two waves shown are primary waves and secondary waves. Primary waves are the first waves to arrive at a seismic station. They shake the ground in the direction they're going. Secondary waves are the second waves to arrive in a seismic station. They're about 1.7 times slower than primary waves, and they shake the ground perpendicular to the way they're going. This wave travels only through solids, so they can't go through the outer core. The reason of this is because the bonds of atoms are only strong enough to move each other in a solid. So if I had a force and I was hitting the corner of a solid, the atoms in the solid would move in a kind of wave-like pattern. So the atoms at the base would probably go this way. Then the atoms above it would go the same way, while the atoms below it go back to their resting position. It would continue this all the way up until the solid either ends or the wave dies. Scientists know what the Earth is composed of due to what kind of seismic waves can pass through it. The shadow zone are zones in the Earth where seismograms can barely pick up or detect earthquakes. The reason these exist are because the waves are produced spherically from the focus and are refracted from the liquid outer core. These waves cannot be detected between 104 degrees and 140 degrees from the epicenter.
This diagram demonstrates Earth's iron core and its relationship to Earth's magnetic field. As you can see, the picture shows Earth's magnetic field moving from the geographic South Pole to the geographic North Pole. The diagram also shows a magnet with the pole going out of the north end and into the south end. The north field attracts to the south field. Geographic north on Earth is actually the south end of Earth's magnetic field. As you can see, these are different. Scientists can infer that the Earth's core is mostly iron because primary waves travel through it at the speed that matches the laboratory experiments on iron. Scientists can measure the gravitational field of iron and can therefore estimate the density of the core. The density of iron closely matches what is expected for the core's density, and since iron is very abundant in the universe, they can assume that this is what the core is made of. The dynamo effect causes Earth's liquid iron outer core to move, generate a magnetic field. This process continues for billions of years. Iron is the best element for producing a magnetic field, which is further evidence that Earth's core is made of iron. Scientists also want to know what elements and types of rock make up the mantle. The mantle is composed of mostly silicates, which are rich with iron and magnesium. This has been determined by studying seismic waves that travel through the mantle. The changes in speed and direction of the waves caused by changes in rock types has helped scientists estimate what elements and rocks the mantle is made of.
Convection is how material moves through the Earth. Convection is caused by heat. This heat is from the core, which heats the mantle and causes the heated material to slowly rise in a convection cell. The core provides the heat, but where does the heat come from? There are four reasons why the core has heat. Heat left over from the formation of the Earth, As the Earth is forming and gaining mass, gravity squeezes materials, adding heat. And radioactive materials decaying also adds heat. When the hot material rises far enough, it gets blocked by the crust. When this happens, the material pushes on the crust, moving it out slowly. When the material hits weaker parts of the crust, the material leaks through and creates volcanoes. Volcanoes can also be formed when heated material creates a hole in the crust, and this leads to a chain of volcanoes.
This diagram is a cross-section of the Earth that explains the cycling of material through Earth. The outermost layers are the plates of the Earth's crust. Convection currents carry hot magma up to the mid-ocean ranges, so material moves up. This material cools and becomes a new part of the plate. This pushes the plate outward. The movement of plates causes seafloor spreading. The ends of the plates grind into each other. One plate slides beneath the other in a subduction zone. This material is pushed down into the molten mantle and becomes a part of it. Then the cycling of the material begins again.
Thanks for watching.